Welcome to The Explainer. Today, we're breaking down some absolutely fascinating new research on how scientists are making medical AI smarter, faster, and way more accurate at spotting diseases in chest x-rays. Okay, so let's jump right in. At the very heart of all this research is this really powerful idea, using artificial intelligence to give doctors a second pair of eyes, an incredibly sharp pair of eyes to help diagnose diseases. And that really is the million-dollar question, isn't it? This is the fundamental challenge researchers are trying to solve, to speed up diagnoses, make them more accurate, and at the end of the day, help patients get the right treatment faster. I mean, think about it. Doctors spend years and years learning to see those super subtle shadows and patterns that might signal a disease. The goal here is to train an AI to do the exact same thing. But to get it right, that AI needs the absolute best tools for the job. For a long time, the go-to models for this were called convolutional neural networks, or CNNs. You've probably heard of them. But now there's a newer and, frankly, more powerful approach that's really starting to take the lead. And this is where the new kid on the block, the Vision Transformer, or VITE, really shines. So unlike a CNN that kind of scans an image piece by piece, a VITE has this special trick up its sleeve called a self-attention mechanism. This lets the AI see the entire picture all at once, and it understands how all the different parts relate to each other, kind of like how you read a whole sentence to get its meaning, not just one word at a time. So, in other words, a VIT doesn't just see a bunch of pixels. It actually sees the relationships between them. It turns a flat, static picture into a dynamic story of interconnected parts, which, you can imagine, is perfect for finding complex patterns of disease. The process itself is actually pretty brilliant. The AI takes the X-ray, chops it up into these little 16 by 16 pixel squares, and then lines them all up in order, just like words in a sentence. Then it reads that sequence to understand the big picture. It's a totally revolutionary way to handle visual information. Now, the researchers in this study didn't just bet on one horse. Nope. They tested 3 different flavors of these vision transformers to really see which one had the most potential. But here's the kicker. A powerful model is kind of like a star athlete. To reach peak performance, it needs a great coach. And in the world of AI, that coach is called an optimizer. The optimizer is really the hidden engine that's driving this whole learning process. It's a bunch of algorithms that guides the AI model, helping it adjust and fine-tune its understanding with every single image it sees, constantly pushing it to get better and more accurate. And that, right there, brings us to the core question of this entire study. Because, just like in sports, different coaching styles can lead to wildly different results. The exact same thing is true for AI optimizers. So the researchers basically set up a competition. They took 6 of the top optimizers, each one with a slightly different coaching strategy, and put them head-to-head to see which one could train these vision transformer models most effectively. All right, the stage is set. Let's get to the main event and see which of these AI and coach combinations actually came out on top. So the scientists used this huge data set. We're talking over 19,000 X-rays. But they didn't just run one simple test. They actually created 2 different scenarios. First, a balanced data set with an even number of images for each disease, and then a much tougher, imbalanced data set that's a lot more like the messy data you find in the real world. And this is where it gets really interesting. What you're seeing here is proof that there is no single winner. The best performing team, the best AI model, and the best optimizer, it actually changes depending on the challenge. It is definitely not a one-size-fits-all situation. In that first scenario, with the nice, clean, balanced set of data, the winner was crystal clear. The standard vision transformer model, when it was paired up with the RA-DOM optimizer, hit a fantastic accuracy of almost 96%. But when things got tougher, with that more realistic, imbalanced data, a whole new champion emerged. The faster FastFit model, coached by the Atom Optimizer, just blew everything else out of the water, reaching an incredible 97.6% accuracy. Okay, so what is all this, these numbers, these names, what does it actually mean? For doctors, for patients, and for the future of AI in medicine? This brings us to the single most important takeaway here. Building a world-class medical AI isn't just about picking the biggest, flashiest model. The real secret sauce is in the details. Choosing the right training coach, the right optimizer for the specific job at hand is absolutely essential to unlocking the highest possible levels of accuracy. And hey, you don't have to take my word for it. The researchers themselves spell it out perfectly. They found that this one family of optimizers, the atom-based ones, were just consistently better, and that tailoring the choice, using R-atom for balanced data and N-atom for imbalanced, was the real secret to their success. Ultimately, what this research really shows us is that we can push the boundaries of AI accuracy by carefully putting together the perfect team for the job. It opens the door not just to better lung disease detection, but to optimizing AI for all kinds of diagnostic challenges. And that leaves us with a very, very exciting question to think about for the future of medicine.